2 marks, so we know it's not too tricky at all, right? Express this in the form x plus a squared plus b. So when we talked about factorising before, I kind of touched on this. This is a complete square. Okay, x plus a squared minus b, exactly the same as that. So this is easier in a way than this question, which is annoying because it's worth the same number of marks because they've actually told us how to do it. Whereas in this one, we had some free reign. Okay, we had to use our common factor, and then we used difference of two squares. So we actually used 2 methods here. So yeah, it's a little bit harsh. We're only getting 2 marks. Let's just let this catch up. Here we go. Sorry, computer seems to be as slow as I am today. Right. So what did I say before then when we do difference of two squares? We don't have a number that adds to give us this and multiplies to give us this. Okay. Actually, we could do. That's really interesting. Yeah, we could actually do not plus. You know what? That's probably why they've told us to do that. We could have said x minus 7. Yeah, x minus 7 and x minus 1. That would have worked, wouldn't it? Because minus 7. Oh no, because then that would give us plus. No, so that wouldn't work. Sorry, minus 7. It'd be minus 7 and 1 or 7 and 1. Yeah, no, so that is. So sorry. Yeah. So you looking at that, you would almost think you could use 7 and 1, but it's not going to work out when you come to add it. So minus 7 plus 1 wouldn't work. Plus 7 minus 1. Yeah, okay, so there we go. Just looking at that, so I thought I could solve that, but I can't. So it tells us to do that anyway. I was just thinking, right. So how do we do this? Well, we look at the first bit on its own. Okay. And the first step is to half the a. Okay. So we're going to say x plus 4 and x plus 4. Okay. So that's going to be our 2 brackets. Okay. X plus 4 and x plus 4. But what we actually then just call that is x plus 4 squared. Okay. So that would give us x squared, 4x, 4x, 4x and 4x gives us 8x. So this is good. Okay, I've got x squared and I've got my 8x. But by writing it this way, I generate plus 16, which I don't want to generate. So I need to take that away. Okay, so I've got minus 7 already from up here, and now I've got minus 16. Okay, so if I add them together, that's going to be minus 23. So it's going to be x plus 4 squared minus 23. Okay, now if we think a little bit about what that means, just while we're on the question, okay, it's obviously not in the question. A standard y is equal to x squared graph might look something like this. Okay, so say that's y is equal to x squared. So when x is 1, y is 1. Okay, 1 and 1. When x is 2, y is equal to 4. Okay, 2 squared is 4. When x is equal to 3, that's 9. Okay, 4 and 16. Okay, so that's your y is equal to x squared. That's pretty standard, all right? We should really know that. I'm just going to get rid of these sketches. Let's rub them out. Maybe I'll rub them out if it lets me. Okay. But what if we move that? Okay, what if we manipulate the formula? Okay, now we've got a plus x squared here. Sorry, we've got a positive term here. Okay, so that's a plus and that's a plus. Okay, so we know it's going to be this shape. If it was negative, it would be down here like this. Okay, so that's the first way to manipulate it. The other way to manipulate it is to move it up or down. Okay, so you can think on this equation actually as being y is equal to x squared plus 0. Okay, now if I did plus 1, it would just move it up by 1. Yeah, if I did plus 2, move it up by 2. If I did minus 2 or minus 3, it would just move it down. Okay, by that amount. Okay, so that's maybe that moves it down by 3 if I was to say y is equal to x squared minus 3. Okay, but we've got minus 23. So actually our graph is way down. It's kind of like way down here. Okay, so it crosses the y-axis at minus 23. Okay, if it was y is equal to x squared minus 23 on its own. Right. This term, the plus 4, that moves it left and right. Okay, so if you forget which way it moves it, we'll just think what makes sense. Okay. This graph here, say that was y is equal to x, say that was x minus 4 squared. Okay, how would I know that that's not right? Well, at the turning point here, y is equal to 0. Okay, so turning point y is equal to 0. If I wanted to check, well, what x coordinate is that? Well, if y is equal to 0, then x minus 4 squared has to be equal to 0. So what value of x is going to give me 0? Well, x is going to be equal to 4. That's going to give me 0. Okay, so not minus 4, 4. Okay, so actually that equation there is x plus 4. That seems counterintuitive because you think on the negative has been over here. Okay, but that's why. Okay, if we think of x as 4, and sorry, in this case, x is minus 4. Minus 4 plus 4 gives us 0. And for that graph, that would give us 0. Okay, so this value in here moves it left and right. So this graph here has been moved to the left 4 and down 23. Okay, so this sign does correspond to going up and down as normal, but that's kind of round the wrong way. Okay, plus 4 means it's moved left 4, and you can just see that yourself by just checking that. Okay, so think of your standard y is equals x squared, which is here, and then think, okay, well if I move it over here, what's that? When's y going to be 0? When x is, in this case, minus 4. Okay, so I've moved it over 4 and then moved it down 23. So actually my new graph looks something like this. Okay, so that's y is equal to x plus 4 squared minus 23. Okay, so that point there is minus 4 minus 23. That's the turning point. So that's kind of in the, see that's why we do this, because it's very easy. We can see instantly the turning point of this equation. It's this number changed the sign, and then this number. That's the x coordinate with a different sign, and then change, and then that number. Okay. So if someone asks for, and a classic question is, what is the axis of symmetry? It's just x is equal to minus 4. We just change that sign. Okay, that's usually what we get asked in these questions. Okay, so again, got off quite lightly in this paper. I think they've just asked us to solve. And again, it's very easy to work back. You could just multiply this out and check you got the right number as well. Okay, but that's just a little bit of chat about what we're doing when we're doing complete square, and we're doing it because of that, because it makes it easier on paper to see what the graph's doing without drawing it. Okay, so always think of your x squared and think, well, how's that moved? Okay, I've moved it up and down, then left and right. Okay, and then you can easily prove if you forget about the sign, am I changing the sign, am I not? Just think, okay, well, if I draw that out and that's x plus 4 squared, does y equal 0 when x is minus 4? Yeah, it does. Okay, if you'd a minus in there, you'd say minus 4 minus 4. That's minus 8. Minus 8 squared gives me 64. Nope, that's wrong. Okay, so yeah, that's just a little bit of chat about those. All right. So 2 marks there, not a lot for factorizing. The next one, simplify the following. Okay, so indices rules. Let's do n squared cubed. Okay, what does that mean? So say I had x cubed. Okay, what am I doing when I get x cubed? Okay, I'm doing x times x times x. Okay, what's 2 cubed? 2 times 2 times 2. It's going to give me 8. Okay, so this is the exact same, right? I'm doing n squared times n squared times n squared. So what's that going to be then? Is it going to be 2 times 2 times 2? No, it's going to be 2 plus 2 plus 2. It's going to give me n to the 6. Okay, because if you think of what that is, n squared is just n. So that's n times n times n, and I've got 6 n's, okay? So n to the power of 6. That's our first bit. So when we're multiplying indices, we add the powers. When we're doing to the power of indices, then we multiply the powers. Okay, so that's 2 times 3 we're doing here. Okay, n2 times n2 times n2, we're doing 2 plus 2 plus 2. If we're dividing, we're taking away. Okay, so if that was n cubed divided by n squared, that's just the same as n times n times n divided by n and n. So we just delete them to leave as n, which is the same as saying 3 minus 2 is 1. That's n to the power 1. Okay. So, yeah, just different ways of thinking about it. That's our first bit. The next bit, we're doing times n to the minus 10. So, again, we're just adding those two powers together. So 6 minus 10 gives us minus 4, n to the minus 4. Now, a lot of people would stop at that point, which is a real shame. Okay, if we've got a negative power there, that is the same as 1 over n to the 4. Okay, that's the bit that people always forget. Okay, that's a rule that's very important. Okay, the minus power is just 1 over. Okay, I think actually that's all the indices we've actually just covered. Yeah, the only one is anything to the power of 0 is 1. So a to the power of 0, yeah, is 1. 5 to the power of 0, 1. Anything to the power of 0 is going to give us 1. Okay, that's the only thing that I can think of that's not been covered in this question. But yeah, 2 into the power of, we're going to multiply, and then when we multiply, we're going to add the powers. Okay, and then the negative is 1 over. Okay, so remember this one. So that is worth 3 marks. Okay, and yeah, you get a mark for this, you get a mark for this, and a mark for this. So a lot of folk there are losing out by the 2 marks. And again, this is another good reason to do these videos, pardon me, because you can see. Well, I try to remember where to put the marks again. I forgot to mark up here. Obviously, you're getting a mark for your A and a mark for your B. Okay. The 2 markers are a bit more straightforward, but for the 3 markers, it's like, where's the marks at? If you see 3 marks, you're thinking there's 3 difficult steps in it. So if you got to here, you'd be thinking, well, why am I getting 3 marks for that? I've only done 2 things. Do you know what I mean? Also, it's not very neat, is it? When you see the minus up there in your head, you're thinking that doesn't look quite right. Do we usually present things like that? Okay, and to be fair, they did up here, but yeah, that's not usually the convention. Okay, they've done that deliberately to make a question. Okay, in fact, sorry, I didn't even read that. There we go. Look, I've done a classic schoolboy error. That's what you fly. I've not read the question, so it actually says give your answer with a positive power. Okay, so clues in the question, which I kind of just battered through and didn't quite read. Okay, so yeah, they do even tell you that. But just keep your wits about you. Think 3 marks is going to be 3 things to do. So getting you to do your multiplication, or getting you to do your addition of indices, and then your 1 over rule. Okay, good stuff. So yeah, 2 pretty straightforward questions there.